Hey guys, what's up everybody? Welcome or welcome back again to another video tutorial from the Apex Academy of Mathematics. We are learning the language of the universe begins here. On this channel, we help to rebuild students. We help them to master your fundamentals, and of course, we find a way to unlock the genius that lies within them. My name is Akin, otherwise known as Apex Academy, and we are back with another special tutorial video. And by the title, you can see that we're going to be talking about special exponents. All right, special exponents, numbers using your perfect square table and your perfect cubes table to use your manipulation technique and skills to help you to learn other different types of numbers that are raised to powers other than 2 and 3. All right, so numbers that are raised to the power of 5, numbers that are raised to the power of 7, we really want to take a look at that and some other skill levels. All right, now if this is your first time here on my channel, of course go ahead, and of course if you are excited to know what I have to offer here, do smash the subscribe button below, smash a like, and turn on your notification bell. All right, so let's jump right into the video and get to learning some math. Now, as you see here, is that one of the most important skills you must have as a developing math student is a skill of manipulating numbers. This is something that is not taught a lot in high schools. Students are just taught to memorize stuff, but memorizing stuff really goes into your short-term memory, and what you want is a skill set that will help you to draw back on these numbers, draw back on these skills to help you when you're in some really tough positions and tough calculating positions. All right, so there are many exponents that you must know, all right, to make other math problems easier, right, to work out. But many students are not able to remember offhand what these exponential values are. So it is important to use what you already know to find out what you don't know, right? So that is really important. So what I want to really do to you today is just go through a little bit of exercise, a little bit of mental exercise with you, and we're going to talk about perfect squares and different special numbers that we need to take a look at. All right, so we first want to take a look at the number 16. We want to take a look at this. There are some numbers that I'm going to highlight here for you. Okay, there's some numbers here. Hold on just a second. All right, good. So here we are. We have the number of course here we have the number 16. We're going to take a look at that, and we also have the number here 81. All right, and we have the number here 64. That's also a really good number to look at. We're going to take a look at number 256. These numbers are really special numbers that we really need to take a look at. All right, also let's take a look at the number 625 and also 729. All right, so these numbers really are going to come in quite handy. All right, we want to take a look at those numbers. Okay, so let's zoom up right here and take a look at the first one. Now, as you can clearly see here, is that 4 squared is actually equal to 16, but 4 squared is not the only exponent. It's not the only way that you can express 16 as an exponent. Here we can look at the fact that 4 squared here, this 4 here, is directly connected to this 4 up here. All right, so 4 squared and this 4. So maybe we can do something. We can alter this 4 squared here and give us something here. So let's look at this. If 4 squared is equal to 16, then we can change this base 4 here into, say for example, 2 times 2. Because here you can see 2 squared, which is 2 times 2, is equal to 4. Now, since 4 is really 2 times 2, and the 4 was being raised to a power of 2, we can raise this part here to a power of 2. Yes? So 2 times 2, 4. And basically this is 4 squared. All right. Now, if we use the power to power property, all right, the power to power property of indices, then we say that here the power on the outside distributes itself to all the numbers on the inside. Let's just write this a bit clearer for you. This is really 2 multiplied by 2 all squared here. All right, so the 2 will square this 2. Okay, the 2 will square this 2 squared here. We're gonna have 2 squared, and then we're gonna have times again 2 squared. So here you can clearly see that 2 squared times 2 squared is still the same thing as 2 times 2 squared. All right, that's the power to power property. Of course, if you want to know what that property is along with other properties of indices, do check the description box below for links to that video. All right, now 2 squared here is 4, and 2 squared here is 4, so clearly you can see it's still 4 times 4 is 16. But now if we use the multiplication property, where we say that when the bases are the same, we add the powers, so this becomes 2 to the 2 plus 2, and that is equal to 2 to the 4. So right there and then, with that little manipulation technique skill, you recognize clearly that not only is 4 squared equal to 16, but you're now learning here that 2 to the power of 4 is equal to 16. This is probably one of the only numbers where you can switch the base and the power and get the same result. It does not work for other numbers. 16 is really a special square number, so I want you to get that concept here. All right, so really check that out. 4 squared 16, 2 to the power of 4 16. All right, so good. So that takes care of that number. Let's see if we can find another number here that will help us to understand how else we can express these numbers as. So we said earlier that we're going to look at the number 64. All right, good. So for the number 64, now we know that here that 8 squared is equal to 64. All right, but if we go across to our cube table on this other side here, we recognize here that we find out that 8 here, this 8 here, is actually 2 times 2 times 2. So 8, the base 8 over here, right, is actually a cube number. So we could convert this 8 here into being, say for example here, 2 multiplied by 2 multiplied by 2, and we're going to of course square it, because 2 times 2 times 2 is 8, and 8 was squared. So here 8 squared, and this is still the same thing, so this is still equal to 64. All right, now again, using the power to power property of indices, we distribute the power on each of these terms here. So we have 2 squared times 2 squared times 2 squared, and that is still equal to 64. All right, so here we could use the multiplication property here, and that states that if the bases are the same, then we're going to add the power. So this really becomes 2 to the 2 plus 2 plus 2, and that's equal to 2 to the 6, so that's equal to 64. All right, so here you're looking at the fact that of course 2 to the power of 6 is 64 also. So 8 squared 64, 2 to the power of 6 is 64. All right, so I hope you guys got that. There's also another way of expressing 64. We want to take a look at that. All right, so here what we have is the fact that 4 cubes is also 64 too. So if you go on your cube table here on the other side, if you go on your cube table here, you're going to realize that 64 is also 4 times 4 times 4. So here we have learned actually 3 numbers, 3 ways of expressing 64. 64 is actually equal to 2 to the power of 6. 64 is also equal to 4 cubes, and 64 is also equal to 2 to the power of 6. Well, it's also equal to 8 squared. We have already written 2 to the power of 6. All right, so it's really good to familiarize yourself with different ways of expressing different squared numbers and cube numbers. All right, so really check that out. All right, so we said that we're going to take a look at the number here, 81. All right, so we want to look at that for you. All right, so for the number 81 now, we have let's zoom it up a bit here for you. All right, so we have the number 81 here. Nice. So we realize that 81 here is 9 times 9. all right, and that's equal to, of course, 81. But remember that the base 9 here is actually equal to 3 squared, and then this base 9 here is also equal to 3 squared, and that's still equal to 81. So 3 squared times 3 squared is 3 to the 2 plus 2 multiplication property. That's equal to still 81. So 2 plus 2 is 4, so 3 to the power 4 is equal to 81 here. All right, so we realize that here, all the way up here, that 81 is equal to 9 squared, and 81 is also equal to 3 to the power 4. So it's really good that you are understanding. If you are so far, go ahead, smash like on the video, smash the subscribe button right now if you haven't, and turn on your post notification bell if you're getting some value from this video. All right guys, so I won't spend a long time going through any more with you. Of course, there are, take for example 256. I really want to touch this one. All right, you can check my other videos. I did do a demonstration on how to utilize the number 27 squared, so you can also check out that video and watch it until you find it there. All right, so for the number 256, we want to check that out here. So we know that 256 is actually equal to 16 squared. That's equal to 256, but we know that 16 is also a squared number, so this is actually equal to 4 times 4. All right, and that's of course equal to 16 squared, which is equal to 256. all right. Okay, so 256. So here now we recognize once again that of course 4 is a squared number, so we can say that this is 2 times 2, and we're going to square it, and then this is 2 times 2, and we're going to square it. All right, so this is basically equal to, I'm going to take out that extra 2 here. All right, so basically we're going to distribute the 2's on the inside. So this is going to be 2 squared times 2 squared times 2 squared times 2 squared. And so we're going to add the powers because the bases are the same. So this is 2 to the 2 plus 2 plus 2 plus 2. And that's equal to 2 to the 2 plus 2 plus 2 plus 2 is 8. So here you're learning that 2 to the power of 8 is 256. I know that probably was a little bit confusing with the little bit of errors or a little bit of writing errors here, but I think you guys kind of get the understanding based on what I've done just before that. So here we find out that 2 to the power of 8 is equal to 256. Now 256 also has another way of expressing it. All right, so if 4 times 4 is equal to 16, then we simply know that this is basically 16 squared is equal to 256. Let's just write that a little bit better for you. So we have 4 times 4 is equal to 16, and 16 squared is equal to 256. So if 4 times 4 is 16 and I square the 16, it means that I would have to square the 4 times 4. Yes? All right. Now, if that's the case, then rather than expressing 4 as a lower base, we can just distribute the power 2 here onto the 4. So we could simply say that then 4 times 4 squared is really 4 squared times 4 squared. And of course, that is as a result of the fact that I distributed the power from the outside onto the 4. So it goes onto here and goes onto there. That's how I got the 4 squared times 4 squared. Now, the bases are the same here. So 4 squared times 4 squared, that's equal to 4 to the 2 plus 2. Multiplication property of indices. So that's 4 to the 4. That's also equal to 256. All right. So really, really cool way of manipulating numbers, guys. All right, so with that said, that's really awesome. All right, there are some other tables over here that you can of course take a look at. All right, it's really good to know all these numbers here. We can recognize that this is also 27 squared here. All right, and of course we could maybe do something to this 512. Let's check it out. We have 8 times 8 times 8, that's equal to 512. But remember that 8 as a base is 2 to the 3, and 8 as a base is 2 to the 3, and that's 2 to the 3 here. Okay, so this is equal to 2 to the 3 plus 3 plus 3, so that's equal to 2 to the 3 plus 3, 6, 6 plus 3, 9. So you learn that 2 to the power of 9 is actually equal to 512. All right, so it's by using what you already know to help you find out what you don't know. All right, very good. All right, so I think that really takes care of the very basic ones that you really want to know. All right guys, so with that said, that brings us to the end of this video tutorial. All right, I hope you get an understanding from it, and of course if you did, don't forget to share the video with your friends and family. Do take care, and I'll see you next time in another video tutorial. Take care. Bye bye.